Hello, this is Miss Moore, and today we're going to discuss covalent compounds. Specifically, we're going to talk about how to name and write formulas for covalent compounds. Today's essential question: what are the rules for naming and writing formulas for covalent compounds? Okay, we're going to start with some terminology. So atoms and molecules. And by the way, these aren't exact definitions. These are my definitions or explanations. So the first one is an atom. So an atom is a single particle made up of protons, neutrons, and electrons. This is something we've been talking about all year, but I haven't put an actual definition to it. So we need to contrast an atom with an element. And some people get confused by this because we have a tendency to use these interchangeably. But when we're talking about an element, it's a group of the same type of atom. So like carbon. When I say the element carbon, I mean lots and lots of carbons. But we're still talking about just carbon. If I talk about carbon atom, we're talking about a carbon atom. One atom made up of 6 protons, 6 neutrons. No, 6 protons, 6 electrons, and then some amount of neutrons. And then the new term is a molecule. A molecule is 2 or more atoms joined together by what we call bonds. So what's a bond? A bond is a connection between atoms through their valence electrons. And we're going to spend a lot of time talking about what a bond is throughout this unit, but for today, just to have a quick definition of a bond. Okay, so we hopefully have an idea of the difference between an atom, an element, a molecule, and that a molecule is formed by 2 or more atoms joined together by bonds. All right, onward to the point of the lecture, which is how to name and write formulas for covalent compounds. So I guess first let's talk about covalent bonds. So a covalent bond is a bond between a nonmetal atom and a nonmetal atom. And that's important to remember because as we progress through the year, we're going to learn about different types of bonds, which are formed from different types of atoms. So again, a covalent bond is a bond between 2 nonmetal atoms. So as a reminder, let me change my pen a little bit. There's this little dividing line here on the periodic table, and everything on the right side here, the right side of the jaggedy line, these are all the nonmetals. Okay, and all the rest over here, everything else are metals. So for the rest of this unit, we're going to spend most of our time dealing with or focusing on nonmetals because we're talking about covalent bonds. One thing that I want to point out is hydrogen. Hydrogen's a little weird. He lives over here in the metal section. He isn't exactly a metal, and during bonding, sometimes he acts like a metal, and sometimes he acts like a nonmetal. So later in the year, we're going to talk about how to tell when he acts like a metal or a nonmetal. But for now, for the rest of this unit, hydrogen's always going to act like a nonmetal. And you can think of him, when he acts like a nonmetal, as living here right above boron. If you have a paper, periodic table, and want to write hydrogen there, feel free to do so. Alrighty, let's name some covalent compounds. Oh, boy, I'm really off here. In a covalent bond, the nonmetal atoms share electrons. And that's going to become more important as we get into Lewis dot structure over the next couple of days. All right, now let's work on naming. So naming covalent compounds. If you remember, the learning objective is what are the rules for naming and writing formulas for covalent compounds? Well, there are different rules for naming the first and second atom in a covalent compound. So there are different naming rules depending on if it's the first name or the last name, but please don't stress too much. It's not that big of a deal. Okay, so the first element named is usually the one written first in the formula and is the least electronegative, meaning the further to the left or the further down on the periodic table. Now, you're not actually going to have to figure that out. The first one written in the formula or the name will be the least electronegative, or the one you're going to be writing first for the other way around, the name or the formula. You'll see in a minute. Okay, so we're going to start. We're going to talk first about the first element named. And if the molecule contains more than one of the same element, for the first molecule, you're going to use a prefix. And you're going to see the prefix for naming covalent compounds, and I'm going to show you that in just a minute. Here's one of the big differences in the first name for this versus the second name. You do not use mono for the first name. Okay. So let me show you the prefix for naming covalent compounds. It's right here. So if you have one of a type of an atom, only one, you call that mono, except for we don't use that for the first name. If we have two of the same type of atom, we use di. If we have three, we use tri. If we have four, we use tetra. I'm not going to keep reading those out. By the way, you can find this prefix for naming covalent compounds on your polyatomic ion chart. All right, so let's try an example. Remember, we're just focusing on the first name for now. So we're going to try this one. Common name, H2O, is water, but let's give it a chemistry name. So first thing you do is you look on the periodic table and figure out what is the name of the H. H is hydrogen. Let me not make that a capital. Let's try that again. Hydrogen. How many hydrogens are there? The second number here tells you, or the second thing there tells you there are two of them. If there are two hydrogens, we're going to use di. So for H2 and H2O, it's dihydrogen. Okay. What if we had, let's try another one, CO2. Again, we're just looking at the first name. So we look on the periodic table to see what that C is, and the C is carbon. There's only one carbon, which might make us want to use, if there's only one, might make us feel like we should use mono, but remember, we don't use mono for the first name, so the name is just carbon. Okay, let's try just one more before we move on. Let's say we had H3. Let's change that. Let's not do H3. Let's do Li3N. Okay, so we look up the first atom, which is lithium. We note that there are 3 lithium. So 3 is tri, so this is going to be trilithium. Okay, again, we're just focusing on the first name. All right, hopefully you feel okay with naming the first atom and using the prefixes. And let's go on to our how to name the second name. So the element with a higher electronegativity value is usually written last, and has the ending "ide." So 2 things about what I just said. First of all, don't worry too much. I wanted to explain to you the rules, but don't worry too much about which one has the lower or higher electronegativity value. I will give you the names and formulas in the correct order. The second is it has the ending "ide." We got to talk about that for a minute. And you always add a prefix to the beginning of the element name, even if there is only one. So we're going to use this prefixes again, but we can use mono this time. All right, so the big difference here is the whole "ide" thing. So what do I mean by that? We're going to be dropping endings and adding IDE. Let's talk about these dropped endings. That's can be a little confusing. So let's write down here. So some dropped endings. So we could drop the ending on, like in carbon. Okay, and we're going to add IDE instead, so it would be carbide. We could drop the ending ogen, like nitrogen, and that would be nitride. We could drop the ending egen, like oxygen, and it would be oxide. Let's see. We could drop the ending ene, like chlorine, and he would be chloride. Let's see, what else? We could drop the ending orus, like phosphorus. He would be phosphide. Which other ones do we have? Let's see, like sulfur. He would be sulfide. Let's see, eum, like selenium. He would be selenide. We could drop ic, like arsenic, making him arsenide. Okay, so that's how you drop endings. You might feel like you need to memorize these. Truth is, though, if you kind of say it out loud, you can refer back to this when you first start this, but after a while, it'll just sort of feel natural what ending to drop and how to add the "ide." All right, so let's look at this again. So again, the element with the higher electronegativity value, the one I'm going to write second, you're going to drop the ending, add IDE, and you're also going to add a prefix. Second, if the name of the element begins with a vowel, drop the vowel at the end of the prefix, which sounds really complicated. Honestly, if you say the word out loud, it's pretty easy to tell. And truthfully, if you get that part wrong, I'm not going to worry about it too much. So let's go back up to our examples and try now. Let's get rid of this stuff. Try now to do the second name. So let's start with H2O. Remember, we figured out the first name was dihydrogen. The second name, we have O, which is oxygen. Oxygen, we're going to drop the E-gen, and it's going to be oxide. And there's only one of them. Do we use mono? Well, we only don't use mono for the first name. So the second name is going to be mon. And it's not going to be mono oxide. That's kind of weird. This is where you're going to drop the ending. It'll be mon oxide. So H2O is dihydrogen monoxide. Okay, let's try the second one. We have carbon for the first name. The second name is oxygen, right? So this is oxygen. We're going to drop egen and make it ide. There are two of them, which makes it di. So this is going to be carbon dioxide. And let's try the last one. We have Li3, which we decided was trilithium. And, you know, I can't continue that one. I know I already did, but that is so not a covalent compound. I hope somebody was shouting that out. So we'll try a full new example here. So let's say, what could we use? Let's use NCl3. And we'll practice both now. So N is nitrogen. It's the first name, so we don't drop the ending. So it's going to stay nitrogen. There's only one of them, but it's the first name, so we don't use mono. So this one's going to be nitrogen. Okay, and then we have Cl. Cl is chlorine. We drop the ene and add an ide, and there are three of them. So we have to use the tri, so nitrogen trichloride. All right, so let me do a quick review on naming, kind of give you little summary rules. So the first name, you add a maybe I won't put that. I'll put add a prefix but not mono. For the last name, you change ending to ide, and you add a prefix. Including mono. And the prefix is the number of the atom in the molecule. Okay. Let's try one more. How about, let's try this one. CO. So, first name, C is the first name. We're going to add a prefix. There's only one of them. So what's the prefix for one? It is mono. But we don't use mono for the first name. So this is going to just be carbon. Okay, second name is O, which is oxygen. But for the last name, we need to change the ending to "ide." So instead of oxygen, we're going to have oxide. And there's only one of them. Prefix for one we just looked up was mono, but we can use a mono for the second name. So it's going to be carbon monoxide. Okay. So that's it for naming. We've got a little bit on formula writing, which is pretty easy, and then we'll be done. All right, on to naming. Let's see, where is it? Here we go. On to formula writing. So writing formulas for covalent compounds, which is actually quite easy because of the prefixes. It makes it super easy. So when writing a formula for a covalent compound, always write the symbol for the least electronegative atom first. Again, I will give these to you in order, so don't worry about that. So really, when writing a formula, all you have to do is write the symbol from the periodic table for the name and write the subscript for any prefix. And a subscript, by the way, is tells you how many of each type of atom. Okay. So again, this really isn't too bad. All right, so let's try several of these. I wish I would have pre-planned. I got to come up with a couple things. So how about phosphorus trifluoride. All right, so first name is phosphorus. There's no prefix, so there's only one. And phosphorus, the symbol for phosphorus is P. All right, now trifluoride. Tri means three, so we know there's three of something. Fluoride. There's no fluoride on the periodic table, but remember we changed the ending. This is actually fluorine. We know what fluorine is. Fluorine is F, and there are three of them. So phosphorus trifluoride is PF3. How about okay, so we have di, which means two, and nitrogen, which is N. So we have two nitrogens, N2. We have tri, which is three. We have oxide. Oxide is oxygen. So we have N2O3. And let's see, should we do one more? How about oh, that doesn't work. We don't want that. We keep using oxygen. Let's change to something else. Okay, tricarbon heptahydride. Okay, tri, we've used this one, is 3, and then we have carbon. So carbon 3. Hepta, Oh, goodness, we haven't used hepta yet. Let's go figure out what hepta is. Hepta is 7. So we have 7 of this thing. Hydride. Hydride. Well, that would be hydrogen. Okay, there you go. All right, folks, that's it for today. Have a good one.